Hey, what's up, man?
Bro, not much.
You have a good weekend?
So I did that one. Yeah, yeah. I didn't really do much. Just had some beers. Yeah.
Cool.
I was hoping it snowed, but it didn't. It snowed in the hills and stuff.
Yeah, just nothing like real.
Nothing crazy. Yeah. What about you? Do anything?
We went to Big Bear. Just hung out with my brother and my
Oh,
parents.
okay.
It was cool.
Yeah, because you guys have a cabin out there, right?
Yeah, my parents do, so it was nice.
Nice.
So
Yeah,
what?
must have got good snow up there.
Yeah, there was a lot. It was cool. So what are you working on? Is it the factoring and the primes still, or?
The last one I did was that. What was it? The zero and something exponents.
Oh yeah. Zero and negative exponents.
Yeah, there you go. But I kind of, I guess I cheated because I just wanted to look at the first one, and then I have that Photo Max app.
Oh yeah.
And then pretty much all of them were photo apps, so I just freaking did it.
Mm.
But I did watch some videos on YouTube on it, and a lot of them turn into like fractions, right? Like if it's a negative, switches over to positive. I don't know that. I'd have to. I can do one.
Yeah, well,
so this is the one.
Was there a test on it?
Stop.
Did you?
No, I'm sure it's gonna be in the freaking the quiz. Once I get to it,
Yeah.
I'll have at least one of them on
there. Okay. The scientific notation. That one is pretty simple. Do you know how to do it already, or you want me to say something before we start, or do you want to just look at it?
I don't know how to do it. It's up to you. I don't care.
Okay,
it's pretty simple. Do you want to do like one of those? You know how to have the base, then you have the exponent.
Yeah. You want me to show
you?
You
can just do one of.
Okay.
Yeah, because that way I kind of know if I freaking run on one because I kind of cheated that whole way through.
Okay. Here, let me share and
just
then...
like one. So it could be like two, to the -6 or whatever,
Okay.
Or whatever you think.
So
I remember you telling me that way about like if it's 6 and then there's a 0 or whatever, it automatically becomes 1, right?
Yeah. So like 6 to the 0 automatically becomes 1. So the answer, like if they said simplify, if that was the instructions, or evaluate, that would mean the same thing, and your answer would just be 1. So anything to the 0. So same with like 1/3 to the 0, that would equal to 1 as well. If you had 2 to the 0 divided by 3, that's different. That would equal 1/3 because just the top part is to the 0. And then the bottom part doesn't have an exponent. So the parentheses here meant that both the top and the bottom had the exponent.
Mm-hmm.
So that's that part. And then if you have like another one, we'll say example 2. If you have something like, let's say 2 to the -4, and the instructions were the same thing. So like evaluate or simplify, like whatever. Same instructions. So for this, the first thing you could think about is taking this and putting it over 1, because every number that doesn't have a fraction or doesn't have a denominator, the thing on the bottom, you can always write it in as 1. So that's maybe the first thing. And then the second thing to do is to take the top part and move it to the bottom. So like this, we'd take that and then move it to the bottom. That would change to multiplication there. There really is like an imaginary 1 out in front multiplying. So this imaginary 1 is the only thing that's left. So on the top, it still just stays 1. And then the exponent becomes positive on the bottom after you move it. So it only changes sign after you move the whole entire base from the top to the bottom. So that means 1 over, and then 1 times anything is just whatever you're multiplying by. So that would be 2 to the positive 4. And then 2 to the 4 just means 2 times 2 times 2 times 2, 1, 2, 3, 4 times. So that would be 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this would be 1 over 16.
Okay.
So starting from this...
sorry.
No, go ahead.
What if there is no negative and it's like just a regular? If it goes down, does it become a negative or?
Yes. So if you had something like, I don't know, let's say 3 to the 4th over any number, 2. If you wanted to, you could write this like as soon as you move this down, then you have to change the sign of the exponent. So, so for it to be like the same fraction, for it to mean the same thing, you could say that this equals, again, there's this imaginary 1 out in front. So then it would be 1 over, and then 2, instead of this 1 staying there, the 2 is going to stay there. So 2 times 3 to the negative 4. We switch the sign. It used to be positive. Now it's negative. And then you wouldn't really evaluate that, but that's a valid thing to do. Like when you have variables, later on that'll make sense, but this is allowed. Doing this is allowed. If you move any number with an exponent to the bottom, you change the sign. If it was positive here, when you move it to the bottom, it's negative afterwards. If it's negative on the top,
how would you figure out that fraction?
This one, you really wouldn't move it in this case, because to figure out the fraction, you would be like, it's easier here to figure out the fraction, because you would just do 3 times 3 times 3 times 3, which would be
divided by 2.
Yeah, 81 divided by 2, and then that would be, I don't know, like 40.2
0.5
or 0.5, yeah. So you really wouldn't do this. You would, like, if you were given a problem where, say, you start out like, let's say this. If you were to start out where it was 3 over 2 to the negative 3. Okay, here, this has an exponent. We can move this to the top. So that's what we'll do. Actually, let me copy this. So we could take this and move it to the top. But as soon as we move it to the top, we have to change the exponent. And again, there's this imaginary 1 in front of everything, but you basically write it in whenever you need to write it in. So we have this 1 on the bottom. And then to evaluate this, you would do 2 times 2 times 2. That's that part. And that would be 2 times 2 is 4, times 2 is 8. And then the 3 still out in front. And then it's up to
Okay.
you. You can write the 1 or not write the 1. And then that would be 24. So that's kind of like example 3.
Cool.
Yeah. That's pretty much like the basics for the rules for exponents. It's just the idea is if you have something on top and you move it to the bottom, you always change the sign of the exponent. So if it was positive on top and you wanted to move it, you would make it negative, and that was going from here to here. If it was negative on top and you move it to the bottom, then you make it positive. That was this example, where you took this and you move it to the bottom, but then it becomes positive for the exponent. And then same idea when moving from the bottom to the top. That was this one. You just change the sign of the exponent. What was it was scientific notation was the topic, right?
This one's going to be introduction to scientific notation.
Okay, so scientific notation is pretty simple. Say we have a number that's like 1, let's say, actually, 32,021. Say that's our number. And if we wanted to write, so this is regular. And if we wanted to convert this to scientific notation, all that means is there's one number and then a decimal point and then the rest of the stuff. And then times 10 to some exponent. It looks weird right now, but I'm just going to show you. It's basically just moving a decimal place. So if we want to write this in scientific notation, first we can think of it just in our heads as 32,021.0. Those are the same number, just because we have the 0.0. But now we have a decimal place. To write it in scientific notation, you always want one number and then a decimal place. So we're going to take this decimal and we're going to move it 1, 2, 3, 4, 4 times. So then I'm going to have 3.2021, and then times 10 to the, I moved it 1, 2, 3, 4 times. So I'm going to say 4 there. Now if you took this, so this is scientific notation. Sometimes they tell you to just like get rid of the rest of the decimals, but we'll see in the problems that we have. But this would be scientific notation. And if we do this properly, actually sometimes they write it like this too. 3.2021 E4. Like exponent is 4. And
okay.
It's just a different way. Those actually mean the same thing. So those are the same.
Cool.
Now to check this, to make sure that we have it, I'm going to type this into the calculator. So 3.2021 times 10, and then I'm going to hit my exponent button, 4, and then equals, and then it gives me the regular version. Does that make sense so far?
Yeah.
So that's going from regular to scientific notation. Another thing, that's if you have like really big numbers. That was like 32,000, like really big ones. But you can also do scientific notation with really small numbers. So if you have something like 0.0001591, this is regular. It's just really small. And to change this into scientific notation, you still want the same format. One number, then decimal, then the rest of the numbers. So you just move the decimal. So I'm going to move my decimal and I'm going to move it to here. and then just count how many times I needed to move it. So 1, 2, 3, 4 times again. So this would be 1.5901 times 10, but since we moved it to the right, this would be negative 4. And then we could check that. So when you're moving to the right, you use a negative exponent. When you're moving to the left, use a positive exponent. And so, again, just to check this, you can always check in the calculator. So this would be the scientific notation. 1.5901. 1.5901 times 10, exponent button, 4, make it negative, and then it gives you the regular version. Does that make sense?
Yeah.
All right, let's see this section. Should be pretty straightforward, I think.
Yes.
But
it's introduction, so I bet.
Yeah, I hope so. So we'll see. Which list is in the order from least to greatest? Oh.
From least to greatest.
Yeah. Okay, so we didn't talk about going from scientific notation back to the original. Can I share real quick?
Yeah.
This will be like a minute.
Don't worry.
So what did it say? What's that? The first number on the first answer.
It's 1.94 times, or yeah, to x 10 to the negative 5. So 1.94 in the multiplication 10 negative 5.
Is that right on the screen?
Let me check. Yes.
Okay. So this is in scientific notation. To go back to regular, you just do exactly the opposite. So from regular, if we move to the right, we'd have a negative. To go backwards, if we have a negative, we have to move it back to the left. So if it's already in scientific notation, then this means move to the left. If it's in regular and we move it to the right, I think we'll just have to get used to. But like if you're going from scientific notation, this means left.
Okay.
Move left. And a positive just means move right. So really all this is going to be doing is 1, 2, 3, 4, 5, because it was a negative 5, so that means move left 5. And I'll just put zeros
okay.
here.
And we just put 0.
Yeah, because there wasn't anything in there to begin with. It's just like what we had here. There was just all zeros. So when we wrote it, there was nothing. And then the whole reason we were allowed to do that is because scientific notation is one single number, then a decimal, then the rest of the numbers. So on this value is that really small decimal. What's the next number for that first answer?
It's 1.25 times 10 negative 2.
Okay, so that means what?
So we're going to do, so we're going to go to the left twice. So it'll just be 0.0.
So then 0.0125. The second one is bigger than this one. Do you see that?
Yeah, so that one's done.
And then the other ones, you're just moving to the right. So it's not like you have to write it down every single time. Uh, but if it does, then
Yeah.
or if it helps, then yeah, write it down. Because what's the next number?
So after that, then it goes 6, 6, just the number 6 times 10 positive 4.
And then the last number?
And that's still on the same. The last one is 8.1 times 10 to the 4.
Okay. So both of these are in scientific notation already. The this one, you can just think of it as 6.0. And then it's still the same thing. So you can just leave it like that. This being positive, so this, whoops, this negative means move left. This positive means move right. So 1, 2, 3, 4. So I'd be 0, 0, 0, and then a decimal. So 6, 1, 2, 3, 4. 60,000. And then same thing here. 8.1, 1, 2, 3, 4. So that would be 8, 1, 2, 3. So that one's in increasing order, right?
Yeah.
And really, you could tell, since these had the same exponent, then really the 6 is smaller than the 8.1. So that means when you move the decimal over the same amount for each of them, this one's still going to be smaller than that one. So that one, like, if they have the same decimal, or I mean, sorry, if they have the same exponent there, you could just look at that decimal.
That number.
Yeah. All right, what did the question say?
I think just from looking at it right now, just from what you showed, I think it's B, but this is from least to greatest, right?
Least to greatest. So smallest one first, all the way up to the biggest one. Well, we did the first answer, right?
Yeah.
And that one was.
So that one's wrong.
No, that was right. The smallest number was
it right? That wasn't the. Oh shit! I can't go back. Wasn't the one?
Oh, you want to see it?
125 smaller than the 194 though.
No, and here's why.
Oh no, because you're going.
There was more zeros.
You added more. Yeah. You're right.
So you're good.
Yeah, so I'm wrong.
There's more zeros there. So it's like a tiny thing. Yeah?
Yeah, because the 124 has a 2. Yeah. Yeah, you're right. This is not too hard.
The fact that there's a negative out in front of those decimals for the answers means nothing. Like, you still convert it the same way. So which answer shows 9 times 10 to the negative 5? So in standard form, I would say take the 9 times 10 to the negative 5, write it down as a 9.0, and then convert it to regular, which means because that exponent is negative.
So you're going to go, we're going, the negative is left, right?
Yep.
So it'd be 1, 2. Is that negative doesn't have anything to do with it?
Oh,
right?
so I was.
Or is it going to be negative?
The number, so that the 9 in the question where it says 9 times 10 to the negative 5, the 9 is positive. So when you convert it, the conversion should be a positive number. The fact that there's a negative exponent doesn't change the negative or positiveness of the actual number. So yeah, it would be the last one. Okay, yeah, I would just convert the scientific notation to the regular, like we've been doing. So
Yeah. So it'd be so 4 1.
yep. Okay, so now it's like the thing I was.
Now I was trying to throw you.
Yeah, it's going the opposite way. Well, I guess what you could do is go from the answers and then go do what it says and then check it against what the question is.
So like, let's say if it was just the 5x 10 minus 2 or whatever, -2, you always write it out as 5.0, or what would you
Yeah, because
always?
5 and 5.0 are the same exact thing. So if there is
Okay.
no decimal, then you can put in the decimal and put it on a 0, and it would be the same exact thing.
I think it's this
Yep.
one, right?
Yep. Okay.
How to kind of flip.
Yeah, they made it different. Okay, I would convert each to like a regular decimal, and then do it in the calculator. Do you want me to show you on one of them, or do you want to try it?
Uh, and then see if I get that right answer, right?
Yeah.
Let me try one out. Yeah, I don't know. I think I'm doing it wrong. If you want to show me,
Okay.
just to get the right
Sure.
answer.
Yeah. 2.06 times 10 to the -2. I'm just gonna write down the first thing, the first answer, and we'll check that, and then we'll go to the rest of them if we need to. So less than 7.69 times 10 to the -2 and 2.3 times 10 to the -5. Actually, there's two ways you could do this. Let's see.
Yeah, because I think I did it wrong, or the way I was trying to put it in the calculator.
Okay. So first way, just trying to put it in the calculator. That might be the easiest, but it might just take a long time. So, well, not that long. I'm gonna just type this in going 2.06 times 10 to the negative 2 equals, and then I'm going to hit the times button, and then I'm going to do 1.88 times 10 to the negative 1 equals, and then see what it gives me. And that'll be this side. And then I'll do the same thing on that. So here, 2.06 times 10 to the negative 2. So 2.06 times 10.
Okay, you do the times first.
Yeah, times 10, and then the exponent button, and then
okay.
2 negative equals. So 0.0206. I'm just going to write it down. You don't have to, but I'm just going to write it down. So it was 0.0206. That's what that was, but it's still in my calculator. So what I'm going to do is I'm going to hit times, and then 1.88 times 10 to the negative 1. So this times 1.88 times 10, exponent button, 1 negative equals. So then, and you can see, like on the calculator, what it's doing, and it should be doing everything. So 0.0038728. So something, and that equaled 0.007, no, 38728. 38728. So that's this side, and then I'm just going to type this in. And this time I'm just going to type it all.
Oh, okay.
Like for me, I had to switch back and forth, but all right, let me see. Okay. So on my calculator, I'm going to go 7.69 times 10 exponent to negative equals. So that's the top part. And then the division might be a little bit weird because the calculator does it a little bit weird. So I'm just going to write that down, actually. 0.0769. So 0.0769. So that's the top. And then the bottom was 2.3 times 10 to the exponent 5 negative equals 1, 2, 3, 4. Okay. 1, 2, 3, 4, 23. And then I'll divide that. So, let me see. So, 0.0769 divided by 0.1234. So that gives you a really, really big number, 3,343. And then some other decimals. This is definitely smaller, less than, looks like an L, than this. So it's the first answer.
That's the first answer, you think?
Yeah.
Or you know? Okay. Yeah, because they have the one, it would have been negative or equals.
Let me see the answers again.
Yeah. A lot of stuff to be put in the calculator, yeah.
And it's all the same numbers, right? Yeah, they're all the same numbers.
Yeah.
Yeah,
just
it's
different grading.
So it's just the first one. So that, yeah, it's just getting used to putting it into the calculator, I guess. Because you'd have to do that anyway, because you wouldn't be multiplying those weird decimals by hand. All right, same thing.
Yeah. Same, right?
Yeah, so
is it the same number?
Exactly the same stuff. What I would do is I would type in 3.56 times 10 to the 2 in the calculator and then write that decimal down or write that number down. And then 1.09 times 10 to the 4th, write that number down. And then divide both of those in the calculator. And then, actually, these ones, you might be able to just convert the first three, like the 3.56 times 10 to the 2. Do you know how to move the decimal on that one? Oh, the stream cut out.
Did it?
Yeah.
I heard you like cutting off. I didn't sure.
Do you know how to change the 3.56 times 10 to the 2? Do you know how to change that to regular?
Like a regular, not non-scientific or whatever.
Yeah.
Yeah, I would just go to the right. I would just go from the 3. I would go twice to the right.
So what number does it turn into?
Then it'd be 3, 5, 6. It'd be 356.0, right?
Yep.
356.
Just 356 or 356.0, both the same. So then,
okay.
Yeah, you could just convert that in your head and write it down. Convert the bottom one and write it down, like without having to type all that in the calculator, and then just divide those two numbers. Those ones are easy to do.
Oh, okay.
Just when it's negative, it's a little bit more
I see
weird.
what you're saying now.
Actually, it's probably easier to just convert it and write it down than it is to type it all in the calculator. And then you just type in the non-scientific notation numbers into the calculator.
And I divide them when I
Yeah, it'll be 356 divided by 1, 2,
10,000.
yeah, 10,090 or whatever, or 900. Yeah. So that's gonna be some decimal, and then write that down.
Yeah, 33266.
And then the 4.08 times 10 to the 2. That one you can convert without having to do it in the calculator. Just convert that. And then same thing with the 1.95 times 10 to the negative 6. Convert that and then multiply it in the calculator.
Now it's the negative, so I got to go forward. So, and you really do like 0.0000195.
Yep.
I got this crazy ass number. I don't know if it's
What'd you get?
let me do it again. I think I got it wrong. $209, $230, $769.230, $7692.
Did you multiply or divide?
I divided.
So on the right side, it's multiply.
Oh, okay. Okay, because it's on top of each other. There's that big slash, so that. Oh, okay.
Yeah, on the left side, it's dividing because it's one on top of the other. with the bar, and then when they're in parentheses right next to each other, that means multiply.
So I got 0.007956.
That's what I got. What did you get on the left side?
On the left side, I got 0.32666055.
So which one is bigger? Do you know?
The 0.32.
Yeah.
So it'd be C, right?
Yep. Yeah, I think it's easier to convert it like by hand and then type it into the calculator. Oh, wow. Oh, so which ones are correct?
So I can just do them all, I guess, right?
Yeah. And there's 4 of them.
So the first one's right.
The first one's not right.
It's not?
No. Because, like, I'm ignoring the right side of the equal sign. So if you look at the 1.71 times 10 to the 3, the 3 is positive. So if you're in scientific notation and the 3 is positive, that means move the decimal to the right.
Okay.
And then they move the decimal to the left.
Yeah, that's what I did too.
Yeah, so I just ignore the right side. And then
let's see. Positive to the right. Second one's right.
yes.
I don't know if you did it, but
Yep. The third one, immediately you should be able to tell whether it's right or not. Do you know why?
yes.
Uh,
Not the way you did it.
you cut out for a second. What did you say?
I just did it. That's all I got here.
But there's a negative on the right side, and there's no negatives. It should still be positive 24,000. That would be the right answer. But they wrote negative, so that one's not right for number 3. Can you hear me? Hello? Oh.
You hear me?
Oh, yeah.
Okay. Yeah, I just laughed at it.
The stream is still frozen from my end, but
I'm gonna share it. Can you see it now or not?
it's still the same as what it was before. The time is frozen at 33 minutes and 22 seconds.
Mine's still going now. Can you see the answers?
Yeah. So
that we were talking about that negative one, right? That's wrong then, right?
Correct. It's wrong.
Yeah.
So that means that 2.4 changing to a negative 24,000. That's wrong. It should be a positive 24,000. So that one doesn't work. Same with the next one, 8.25. That's positive, so the other number should be positive. And then the 7, can you hear me?
Yeah, I can hear you.
The 7.09 times 10 to the negative 6. What do you think for that one?
I think that was wrong, right?
No,
because it's adding zeros.
Yeah, the negative 6 means move the decimal to the left.
Oh no, not that one. I was looking at the 390. Yeah, never mind.
Oh,
yeah,
okay.
That one, I think that one's correct.
Yeah, you're right. The 7091, that one's correct, and you're also correct on the other one, the 3.99. That one's wrong because they put zeros in there. Yeah.
So it only needs these last two to be correct.
Yeah, they have to. Yeah.
Select one.
Oh, there we go.
All right. Here's the easy ones, right?
Which number is equal to 10 to the negative 3? So again, well, oh yeah, this is actually the fraction one.
So this
is not scientific notation. This is like what we talked about at the very, very, very beginning.
This is the 0 and so this would be -3 or whatever the hell, or just 10 times 10 times 10. So it'd be -30.
That would be 10
no,
plus
wait,
10 plus 10.
No, never mind. Let me calculate it.
Yeah. And they're mixing stuff in, so this is going to be confusing, I feel like.
Yeah, they tell you what. So it's a -1 thou. See?
No.
That one wrong?
But here's why. I'm going to share.
Okay.
And this is kind of like, this one's dirty.
My first was I thought it was going to be like the 0.003 or whatever.
It's close to that, but here's the thing. So the problem that is on the screen, 10 to the negative 3, that's exactly like this one, where we have, let's say, 2 to the negative 4. You take the bottom, it has a 1 positive there. Yeah, you take this and you move it down, and this also has like a 1 there. So it'll be 1 over 2 to the positive 4 times 1, but you don't need to write that because anything times 1 is itself. And then you do 2 times 2 times 2 times 2, which ended up being 16. So on this, 10, what is it, to the negative 3?
10 to the negative 3, yeah.
Okay, there's like times a 1 and also a 1 on the bottom. So you take this and you move it to the bottom, but as soon as you move it to the bottom, then
it turns positive.
Yeah, it turns positive. Whoops. And then so now there's this 1 in the top from there, and we have 10 to the 3, and 10 to the 3 is 10 times 10 times 10, which was 1,000.
Mm-hmm.
So it would be 1 over 1,000, and then you just do that in the calculator.
Okay.
So it's the third one, I think.
What? Well, that would confuse me.
Yeah, that was not even scientific notation, so they just threw that one in. Alright, which answer shows this written in scientific notation?
So it'd be A, right?
No, because scientific notation has to have one number, then a decimal, then the rest, and that first number. I don't think I said this before, but it can't be 0.
Oh, okay. So it'd be B.
Yeah. So like that first thing, if you
Yeah.
do all the rules, it does come out to the correct answer. The only reason it's not the correct answer, or like not the correct choice, is because of that 0, and that 0 in front of that decimal means it's not yet in scientific notation.
I see.
And so yeah, it's B. But I don't think I said that before.
No, I don't. You said it came up.
Yeah. Do you see any answer choices?
I don't see anything. They're gonna get us with this one.
Oh, there we go.
Which number is written scientific notation? So it's definitely not C, right? Because it can't have the.
Yeah, it's definitely not C. Oh, this is a clever one. Yeah, because so that was just the same thing that we just talked about. C, it has the 0 in front, so that can't do it.
So what are they trying to do with this?
Well,
I mean, anyone can be written in. Besides that one, right?
well, it's saying
There's
which
no
one
decimal.
is in scientific notation already, and there's only one of them that's in scientific notation. Let me share real quick, and then I think you'll see. Okay, so scientific notation means a number, a decimal, and then something else. There can only be one single number here, and it can't be 0. And then times 10 to some other exponent. So this has to be a 10. So that's why one of them's wrong. And then this has to be a single number. That's why the other one's wrong. Do you notice?
Yeah, the one has a 7.
Yeah, so that one's not right.
So it's got to be 12 times 10 to the negative 8. Okay.
Well, the 12, that has two numbers. That would be, if you change it to a decimal, that would be 12.0, right?
Well, it has to have just a.
Yeah, it should be 1.2 times 10 to the negative something if it was in scientific notation. So that's the only one. Yeah, the first one. That was a tricky one, too.
Yeah, that's a big issue.
Cool.
Let's see what they got next and see what the hell. All right, so they got a topic test.
Do you want to just do it?
Yeah, this is gonna be so. Like after I do this one, then they'll have me do the actual It's like a review, but we can do it. Should be quick. I think it's only like 15 questions, so.
Okay.
Which would be good practice.
Estimate the following product in scientific notation and then select the best answer for the product's power of 10. Oh.
So this you would do. You would just put in the calculator, right?
No. They're having you do it in a fancy way, I think. Estimate the following product in scientific notation. Estimate. And then select the best answer for the product's power of 10. The answer is B.
How'd you get it? Just like that?
I
know you know.
So when it says estimate, one way that you can estimate the following product in scientific notation. I think what they're doing is 8.91 times 3.3, and then they would write that down, and then the 10 to the 2 and the 10 to the 12, they take those exponents, the 2 and the 12, and they add it together to get the 14. Because it's asking, select the best answer
power,
for the product, or for the product's power of 10. So it's asking for the power, which is like an exponent rule that they haven't even introduced. But the shortcut there is when it says estimate and it's asking for the exponent, you just take the exponents for the 10 and you add them. That's a weird one. Hopefully we'll see another one and we'll try it. But two best. Okay, so that last one that we did, we added the exponents because we were multiplying those two numbers. Here we're dividing these because that big division bar. So the exponents we would subtract. We would go 9 minus 5. I don't think they went over these, or maybe they did, but this is weird.
Yeah, it's weird. Those two little squiggly lines just mean it's an equal sign, right? Written in a fancy form.
It means approximately equal to.
Okay.
I don't know actually how they get the 3. What if you do 6.33 in the calculator? 6.33 divided by 1.79. Oh, maybe you just round it to a whole number. Like 6.33, you round that to 6. And 1.79, you round that to 2. So 6 divided by 2 would be 3.
Yeah.
And then you subtract the exponents. Do you want me to show you on this one?
Yeah.
All right, so you can put in 4 and then save and exit.
Oh, I don't think this one's timed, so we're fine.
Oh, it's not?
No.
Okay, let me just share.
Before would be the answer?
9. Yeah. Because it's asking just what is the M.
Oh, okay.
So this is an exponent rule. Before we had, I'm making up something actually. Say we have 3.24 times 10 to the 8th. And this is multiplication. So let's say 1.94 times 10 to the 3. Okay, so on this, I think when they say estimate, they're rounding this to the nearest whole number. So since this is a 2, it's smaller than 5, we would just round this down to 3. And then they would round this to the nearest whole number. Since this number is 5 or bigger, we round the whole thing up. Does that make sense so far?
Yeah.
And then, so that would be 2 times 10 to the 3. And then they're just doing 3 times 2. That would be 6. And then times 10 to the, and then you have to figure out that part. And here we would just add 8, 9, 10, 11, and I'll show you why in a minute. So that would be the estimation if the instructions were to estimate. Now here's why. If you have, say you have 3 times 2 times 4. If it's all multiplication, it doesn't matter what order you do it in. If you do 3 times 2, that's 6, and then 6 times 4 is 24. It doesn't matter if I wrote the 4 first, and then the 2, and then the 3. I would still get 4 times 2 is 8, and then 8 times 3 is 24. If it's all multiplication, it doesn't matter the order that you write it in. So far, so good?
Yeah.
All right. The next thing is, this is multiplication. It's just not written like a dot, but it's still multiplication. Also, this is multiplication between these two things. And same with this. That's also multiplication. So it's a similar situation to this. We can write it actually in any order that we want. That's why we're allowed to get this 6, because like the thing that's actually happening is 3 times 2 times 10 to the 8th times 10 to the 3. Does that make sense?
Yeah.
So I just moved this out in front and then grouped those things together. Then the next thing is, why the heck did we add the 8 and the 3? Well, if you remember, 10 to the 8th is just, I should have picked a smaller number. 3 times 2 times 10, 1, 2, 3, 4, 8 times, yeah? I gotta write it out. 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's 10 to the 8th. 10 to the 3 is 1, 2, 3. So far, so good?
Yep.
All right. The reason we add them is if you just count all of them all together, how many do you get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I have it 11 times, that's the same thing as times 10 to the 11. The shortcut is just to take this and add it to that to get the 11. And then so we have 6 times 10 to the 11, and just to make it look like scientific notation, you can use the x for multiplying. So far, is that okay?
Yeah.
All right, so when you're multiplying, you can add the exponents as the shortcut. If you're dividing, same thing happens. You round in the same way, round to the nearest whole number, round to the nearest whole number. But if you're dividing, say we have 1 point, no, let's do 6.02 times 10 to the 4 divided by 3.12 times 10 to the 2. I'm going to do the same steps here. Round and round. So this would be 6 times 10 to the 4 and 3 times 10 to the 4. No. Times 10 to the 2. And then I'm going to write that out as 6 times 1, 2, 3, 4. And then 3 times 1, 2. Oh, that's it. Okay. So now, like, it's all written out except for I'm dividing. And when you're dividing and you have the same thing on top as you do on bottom, it cancels out. So that cancels, and that cancels. So I'm left with 6 times 10 times 10 over 3. I can divide the 6 and the 3, that's 2. And then the 10 and the 10, that would be 2 times 10 squared. So 6 divided by 3 gives us the 2. The shortcut, just like over here, we added. Here, you just subtract. 4 minus 2 is 2.
Okay.
So with division, you subtract the exponents. And with multiplication, you add the exponents to get that. That one took a long time. Sorry.
That's all good.
Yeah, let's see what else they got.
After we do this one, it'll lock, and then the teacher has to unlock the test.
Oh, okay.
So this one would be one of those prime numbers, right? The first course that we did. So it would be 51, right?
I think so. So the way I would make sure is can I divide 51? I can't divide it by 2. Can I divide it by 3? Oh.
Yeah, you can.
You can. So I would just start trying.
So 55.
55 divided by, can't divide it by 2. Divided by 3, no. 55 divided by 4, no.
You can't by the 5 though.
Yeah, so it's not that one.
How far would you go?
That's
what number?
That's the next question. So here, let me share. Okay, so the numbers are 49. What was it? 49, 51, 53.
51, 53, and 55.
So you could start, this is one way to do it, but it's the longest way to do it. You could start at 1 and divide by every single number all the way up until the actual number 49. And if nothing works, then it's a prime number. But that's the long way to do it. There's a little bit more clever way, and I'm going to show you with a different number. So let's say, let's do 32. So first I would just do this all in my calculator. I wouldn't write anything down, but I would just do it in my calculator and kind of keep track. So 32 divided by 1. Ooh, actually, this is going to work out. Let me do a prime number. Let me do 29. Okay, so I would start out with 29 divided by 2. 29 divided by 2, and that one doesn't work. 29 divided by 2, I do it in my calculator. 29 divided by 2 doesn't work. It needs to be a whole number for it to be a composite. Right now we don't if we don't get any whole numbers, that means it's a prime number. So 29 divided by 2, done. That gave me 14.5. 29 divided by 3, that would give me. Here, actually, so I don't have to keep switching back and forth. Can you do it on your? Oh, actually, I got it. 29.
Yeah, I can do it on my calculator too. That way.
Yeah, okay.
I was doing that with the 53 just to.
But so I'm gonna try and show you when you can stop because you don't have to actually go all the way through. So 29 divided by 3 is 9.6. 66667, right? What's 29 divided by 4?
7.25.
7.25. Okay, that doesn't work. 29 divided by 5?
It's 5.8.
5.8. 29 divided by 6?
It's 1. Which I don't know how the hell I'd get that right. 29 divided by 6? 4.8. Yeah, I must have left the last one. 3.
Okay, so here's the thing. When like we're going to like we don't actually have to go anymore.
Okay.
Because here, this is the way I'm gonna think of it. This number is bigger than this number, right?
Yep.
When that switches over, so like this number is still bigger than this number. This number is bigger than this number. This number is bigger than this number. It switched over. This number is now smaller than this number. You see that?
Yeah.
And the reason for that, so like here, I don't have to actually keep dividing anymore. I've done them all. 29 is prime. I should have showed you with a better number. Let's do a small number, 8. If I did 8 divided by 2, that gives me 4. 8 divided by 3 doesn't work. 8 divided by 3, 2.6. 8 divided by 4 equals 2. Already, I'm going to run into the same thing. Like 8 divided by 2 is going to be 4. 8 divided by 4 is going to be 2. Whenever it switches over like that, I don't have to keep going because I know all the rest of them aren't going to work out. I don't know if that very well explains it, but as soon as you...
Once it gets smaller...
Yeah, once this number gets smaller than what you're dividing by, you can stop. That's the shortcut. So with 49, 49 divided by, let's see. This is what I do on my calculator. 49 divided by 2. Nope. 49 divided by 3. Nope. 49 divided by 4. Nope. 49 divided by 5. Nope. 49 divided by 6. Nope. 49 divided by 7. That works. So this is not
a prime.
And then 51.
Right. So I did the 53, and I haven't got one yet. And then it got smaller than the number I divided.
Yeah, so that's I guess the way that you don't have to keep going all the way up to 53.
Yeah, to that number. All right.
What do you think on this one?
It's 1.
Yep. Anything to the 0. Even if it's just a letter.
Million,
yeah.
Right.
Oh, which are correctly written in scientific notation. So it has to be a times 10 to an exponent. It has to be a 10. And then there can only be one number in front of the decimal, and that number can't be...
It could only be 1. Okay.
Yeah, it can
so
only
the 17.1, there can't be 2.
Right, there's 2 numbers in front of the decimal, so that's not scientific notation.
So I would say this one's another correct one.
Yep.
And the last one would be...
Yep.
Because that last one has a 1 on it.
Yeah, I didn't even see the 4 to the 3, but you're right on that one. The 6.25 with the 4 to the 3. Yeah, you're good.
So this one, the composite was that you can divide into, right?
Yeah. So if you find a number that divides, it's just basically the opposite question as the prime question.
So it'd be 33.
Yeah.
Because that one you can divide by 11.
Mm-hmm. Okay.
I think we did this one, remember?
If we didn't do this exact one, it was something really similar.
Yeah, that's true. They could have worded it different.
Maybe you did this one. I don't think I seen this
But
one.
I don't think I did, actually. No.
Oh, that's a weird way of writing it. Do you
You
know?
should have done like 2 times 24 or something first, right?
Yeah, well, they did the
Get down there.
they did the prime factorization, so they did it all the way, and then only wrote down the numbers at the end of the little tree thing.
Oh, yeah, on the left side.
Um. Okay, so the greatest common factor is 2 times 2 times 2 times a single 3. So like 3 2s and 1 3. How can I explain this?
So he's wrong with his answer.
Yeah. Well,
Brian did not list all the factors of the prime.
here, let me show this one.
Right.
So 48 is 2, 2, 2, 2, 3. So he has this, yeah?
Yeah.
So the greatest common factor means what's the most things that I can include that's present in both numbers or both factorizations. So
The 2s, right?
right there's a 2, but there's more than that that's in common. There's 2 2s, but there's still more than that that's in common. There are 3 2s, but there's still even more than that that's in common. It's those 3s. That's actually the most that's in common. You can't say there are 4 2s in common because this one only has 3 2s. So the most that you could say that is in common is 3 2s and a 3, because both of them have 3 2s and a 3. So far, does that make sense?
Yeah.
So the greatest common factor is the most things that are present in both of them. So that would be 2 times 2 times 2 times 3, because this is present in both of them. So that's the greatest common factor. He didn't do that. 2 times 2 times 2 times 3 that ends up being what, 2 times 2, this is 8, yeah, that ends up being 24. That's not even part of what it's saying. The least common multiple is what he did. And the least common multiple, remember, factors are always smaller than these numbers. Multiples are always bigger than these numbers. So he wrote out the prime factorization, and then to get the least common multiple, he's pretty much looking at this and saying, okay, what does this have that this is missing? Well, this has 2 3s, so I need to add an extra 3 or multiply an extra 3 onto this one. So now they both have the same amount of 3s. But this one has 4 2s, so I gotta multiply another 2 just to keep it. He's gonna multiply another 2. Now these are the same thing, right? Mm-hmm. And since I multiplied by numbers on each of them, they're considered multiples of these, and it's a common multiple. So the smallest or the least common multiple is this number, because that's the smallest thing that you have to multiply to each of them so that they end up being the same number. And I don't even know what number that is, but it would be what, 2, 1, 2, 3, 4. Is that 16 times 9? I don't know. Some number.
Okay.
2 times 3 times 2. 144. So both of these are equal to 144. That's what he found. That's what he wrote down.
Okay.
But it was a weird one that, like, I don't know. When you're multiplying things and it makes it bigger, those are multiples. If you're factoring it and you get smaller numbers, those are considered factors. I don't know. I don't think I explained that one clear, but it's the last one. Ryan found the least common multiple instead of the greatest common factor. Well, we'll see another one like that if it comes up. Hopefully.
For sure.
Kia thinks that every number has at least 2 factors, which explains whether Kia is correct.
And the factor is just a number that you can divide into it?
Yeah, and then the answer, so like a factor is a number that you can divide and then also still get a whole number.
So it'd be 1 is a factor, right?
Yep, because you can divide by 1 and then you still get a whole number.
It'd be A.
So
It's not incorrect, right?
Kia is correct because prime numbers have 2 factors. That's true. You can always divide a prime number by 1, and you can always divide the prime number by itself. And composite numbers, you can do the same thing, but also more. So that statement is true, but this one's like a trick question. Kia thinks that every number has at least 2 factors. The bottom answer is correct because 1 is the only number that has one factor. So not every number. 1 is the exception.
Oh, okay.
Does that make sense?
Okay.
Like,
I'm going to say yeah.
Kia thinks every number has at least 2 factors. So the number, like if you start 0 has to have 2 factors, 1 has to have 2 factors, 2 has to have 2 factors, 3 and
Oh,
like
but
forever.
1 does not. Yeah.
Yeah.
1 is 1. Yeah. Okay. Yeah, I got
It's
it.
the only one that makes the situation not true.
Nice.
Otherwise, if it said like Kia thinks every number greater than 1 has at least 2 factors, then A would be true because then you're not counting that one. But that one's a tricky one. Evaluate the expression that has a value of this. Each expression. Could Jane have evaluated? Check all the apply. If you know how to type those into the calculator, that's what I would do first. Or we just do the exponent rules.
So it would be -9, not
Say it again.
Well, so the first one would be -9, right? Because the negative's inside the parentheses.
Yeah. I don't know if we've talked about the 1/9 to the -6 or the 1/3 to the -6.
Yeah, I don't think we have. Or I don't know if it showed it in those 10 answers there, or the 10 questions that it asked.
Yeah. Can I show you on this one?
Yeah.
So it's asking like what is the same as this, right? That's what it's asking?
Yeah.
So here there's no way for it to become a fraction because this is already positive, which means this stays where it is. Like you could write over 1, but you don't have to move anything because the exponent's already positive. So like if you just wanted to be sure, you could do -9 and then raised to the 3. So we could do 9 negative exponent 3 equals -729. I mean, that's close.
Yeah, that's negative.
But we want 1 over, so that one is not the same as this. And the only way we can get 1 over is if it was a negative there, and then it would be 1 over. But so that's not the answer. So that one doesn't work. This one, if you want to use the rules, that's the same thing as putting it over 1. And then since this is negative, when you move it down, it becomes positive. And there's like a 1 on the outside there. So it would be 1 over 9 to the positive 3 times that 1 from the bottom. And then so this one would work because we would have 1 over, and then 9 to the 3, we already saw that that was 729. So that one works.
Nice.
Does that make sense?
Yeah.
And then, what about this? So, let me get some room. So, same idea. We can say, okay, there's a 1 on the outside there, and then a 1 on the bottom that we can just put in. Since this is negative, we can move it down. Once we move it down, we have the 1 on the top from here, and then 3 times that 1 that we don't actually need, but to the 6th. And it's positive now because we moved it. So 1 and 3 to the 6th. So I would say, what is 3 exponent button 6? That's 729 also. So
that one's right.
Yeah. So that one also works. This one is not right. You know how if you have a negative exponent, you switch places? You put it to the bottom, or if it's negative on the bottom, you put it to the top. Like we had well, if it's negative on the top, you move it and put it on the bottom. If it's negative on the bottom, you can switch it to the top and make it positive.
Okay.
So, oops. When you have a fraction, this is just the shortcut. If you have a fraction here with a negative exponent, the long way of thinking about it is, actually, I'm just going to show you the short way. You can switch the fraction and make it positive.
Oh, okay.
So just like you switched the position and made the exponent positive, well, if it's a fraction on the inside, then you switch the whole fraction and then make the exponent positive. Like, yeah, that's it. I'm just going to leave it like that.
How do you solve it, though? Do the same.
Yeah, so this 9 over 1, that's the same thing as just regular 9, right?
Yeah.
And then so you just do 9 to the 6th. Cool. The long way of doing it would be like 1 over 9. Well, actually, no, you'd have to switch it first. Yeah, that's it. It would be 9 over 1 times 9 over 1 times 9 over 1, blah, 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 blah. 1 times 1 times 1 times 1, 6 times is still just 1. And so that's why it's the same thing as that.
Okay.
Same idea on this one. We can just flip the fraction, so 3 over 1, and then make the exponent positive, which is the same thing as just 3 to the 6th, which is not going to work because that will just give you 729. We want it to be 1 over that, so this one doesn't work. And then this one still doesn't work because it's like over 1.
Negative, right, too?
Yeah, and it's negative. So on this, it's weird when you do it on the calculator because this is even. Just to make sure. If I did 3 to the negative and then exponent 6th. Oh, it does it correctly. Okay, good. Never mind. So that one also.
But that one's wrong.
Yeah.
Oh, it works. Or it's wrong.
It's wrong because it's 729, not 1 over.
Not 7. Over 1, right? Or 1 over.
And that's just because if this was negative, then it would work out, but it wasn't.
Oh, okay.
So it's the 1, 2, the second one, the third one, and the 5th one, right? The 9 to the negative 3, the 3 to the negative 6.
3 to the 6. And then the last one. No, it wasn't the last one, right? Because that was
actually,
just 729.
I think it was just those two.
Check all that apply.
Yeah. Okay, least common multiple of two numbers is 36. Which could be the two numbers?
The least common.
Okay, easy way to do this is to write out the multiples of 9, like write out 5 of them, and then write out 5 multiples of 12, and then see which one's the smallest common one. Do you want me to show you?
Yeah, so it'd be like for the 9, 3, 6 for the 3 and 6 for the 12.
Those would be factors. Factors are smaller than the number. Multiples would be like 9 times 2 would be 18. So 18 is a multiple of 9. 9 times 3.
And then that would equal.
Yeah, so like multiples, you just start by multiplying. So like we have, what was it, 9 and 12. Multiples mean you just start with 1. 9 times 1 is 9. 9 times 2 is 18. So 9 is a multiple of 9. 18 is a multiple of 9. I'm just going to write out 5 of them and we'll see. 2. So 9 times 3 is 27. 9 times 4 is 36. 1, 2, 3, 4. 9 times 5 is 45. And then I'm going to, so those are all multiples of 9. And I could keep going. I could just keep going on forever. But I just wanted to write out 5. If I need more, I'll write more. And then I'm going to do the same thing, but for 12. The multiples of 12 are 12, because 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60, I think. So the least, so these are both sets of multiples. These are all multiples. The top is multiples of 9. The bottom is multiples of 12. The least one that's common between both lists is 36. So that one works out. I could keep going. Like 9 times 6 is 54. 9 times 7 is 63. 9 times 8 is... What's 9 times 8? 72. I think. I don't know. 9 times 9 is 81. 9 times 10 is 90. 9 times 11, 99. 9 times 12 is 108. I could do that and then do this all the way up. 12 times 6 is 72. Is that true? 12 times 6. Okay. So 12 times 6 is 72. There's a 72 there, yeah?
Yeah.
That is also a common multiple, but it's not the least common multiple.
I see.
Because there's the 36 is in common. So you just write out a couple multiples for one number, write out the multiples for another one, and then the smallest one that's in common is the least common multiple. That's the easiest way, I think, to think about it. And then multiples are just, you start at 1 and times 2 and then times 3 and then times 4. Factors are when you're dividing and making smaller numbers.
So, let's say, so 4, 4 times 1 is 4, then 4 times, 8, and then, so it'd be 12 and 12. But this one says the least common multiple of two numbers is 36. So it has to catch on 36, or what's that mean?
It has to catch on 36, and that has to be the smallest one that catches. So, when I wrote it out, it caught on the 36, but it also caught on the 72.
But it was the smallest was the 36, right?
Yeah, smallest was the 36. If you do 4 and 6, it'll catch on 12, and it'll also catch on 36. But the least common multiple for that one would be the 12 because it's smaller and it caught on both of them. Does that make sense?
Okay. Yeah. So like that's the one right there.
Yeah. So 36 is a common multiple for all of them, but there's other ones for the 4 and 6. Something gets caught before. For the 3 and the 8, something gets caught before 36, and then for the 3 and the 12, something gets caught before the 36. All right, this is the one where you make the tree and you just divide until you can't divide anymore. Do you want me to show you, or do you want to try it?
No, I know. So I'll do the 84, and then I can do like 2 times whatever. 84. So what I got for this one would be the 223.
223 was the.
That's just the left one, but at the bottom it was 37. So
yeah, and you can't divide the 7. So it's all
so
of
it'd be
the.
B, right?
It would include the 7.
Oh, it would include the 7.
Yeah.
So it would be B, right?
Yeah. And so the reason, like, you're not just doing the left ones, you're doing all of the ones that you can't divide anymore.
Okay.
Because those would be prime. Like, if you can't divide it by anything other than 1, then that's when you stop and you include it. If you can divide it, then you keep going, and you keep going, and you keep going. Actually, I want to show you something on that one.
All right.
It'll be real quick. Did you write it down like this?
Okay. Yeah, that's exactly what I did.
Okay, so
I just didn't know about the 7.
Right.
That was included because I thought just the left side.
Yeah, so it's both of them. This is why I wanted to show you. If you do, because you can do it in a different way. Like say 84. Well, yeah, let's do 2 because that's the easiest one. When it's even, you divide by 2. So this would be 42. But then on this one, I'm thinking 6 times 7 is also 42.
Okay.
I can't break this one down anymore, but I can break this one down. So I'm not just doing like the left side. I'm doing anything that I can break down. I don't keep going on this one because I can't break it down. But the 6, I can do 2 times 3. And then now I can't break these down either. So it's 2, 2, 3, 7 still.
Okay.
Does that make sense?
Oh, I see. Yeah.
So you're taking all the ones that you can't break down anymore. That means it's prime.
Those are going to be.
And so that's why you call it the prime factorization.
Cool. So that'll be
that's a trick. That's a tricky one, or like
it's
a
not
trick
going to
question.
be 1, right?
It will be 1.
It will still be 1.
Yeah, because you do the inside first. So the 2/3 to the 0, because the 2/3 is in parentheses. That means all of that to the 0. That changes to 1, and then 1 to any exponent is going to be 1. Do you want me to show you on that one real quick? Or
yeah, no, you can do it. Let's do it.
All right. So 2 over 3 to the 0. You understand that that's 1, yeah?
Yeah, I just broke it
Okay,
down.
so then we're looking at this part. 1 to the negative 3. Well, that, you can always put it over 1 and times by 1. That's what we've been doing. So this negative 3, that's the same thing as writing it like 1 times 1 to the negative 3 all over 1. You just move this to the bottom and then make it positive. So it'll be 1 over 1 times 1 to the 3. Well, 1 times 1 times 1 still is 1. So it's just 1 over 1, which is just 1.
Got it.
That's a trick question, I think.
Right.
Okay.
Gonna be one of those ones.
Mm-hmm. Oh, so they're asking for the greatest common factor.
So it's gonna be the biggest.
Yeah, the biggest
Of
one
both
that's
these
also
numbers.
in common. Oh, and they already did it. They already wrote down the factors for you. Okay. So what's the greatest common factor for this?
It would be 96.
So those are
From the answer, right?
that's a multiple.
Oh, okay.
So if you write out the multiples, it would be the least common multiple might be 96, but the greatest it already wrote out the factors for you. 12. The factors are 1, 2, 3, 4, 6, 12. And then the factors, like this one's a different one than that other one.
Okay, I was going based off the other one.
So this one's...
So it'd be from 8 and 12, right?
Yeah.
Before.
Yep. So in both of the things, so when it says greatest common factor, I think the easiest thing is, write out the factors and find the biggest one that's in common. For the least common multiple, you write out like 5 multiples like we did on the other one, and then you do the least common one, the smallest common one. So you just gotta see like which type of problem it is.
Like the wording too, not the wording, but the, I guess like all the names, you guys have.
Just the name.
Certain numbers, I guess. So this one's 1.
Yep.
Those are the easiest ones.
Yeah.
Which expression?
Does that confuse you, the 64 to the 1, or do you know what that means?
Well, it's not going to be... I don't know. I guess I could just multiply all these and see which ones I get, right?
Yeah. The 64...
It's going to be 64, right?
Yeah, it's just 64. So, like with the 1, it just means 64. I'll do that too.
So the first one plays out.
Yep.
What does it?
Yep.
I'm about to go back and do that one. I got 64, but I just want to make sure I did it 8 times.
You could use the exponent button. Do you remember how to use the exponent
Oh
button on your
yeah.
calculator?
Yeah, I forgot about that shit. 2 times. So the 2-8 one's wrong, right?
It's it doesn't give you 64.
Yeah, I get you. All right, I think that's the only ones.
Do the last one.
Let me do it. Yeah, okay. Yeah, that one got it. So this one doesn't tell you what you got.
Oh, doesn't it? Oh, it only shows it to the.
No, it's like a pretest, yeah.
Oh.
So now, see, she has to open it up, and it'd be one of those 25 question ones.
Do you think she'll open it up sometime tomorrow? Then.
Yeah. So tomorrow is like actually it's when people have class. So if you want to go talk to her, you can talk to her. So I'll email her in the morning, and then she should open it up before we get. She usually gets on like around 6, because that's when her class starts, I guess.
Okay.
So she should have it open. I usually email her and I hit her, and I'll send her a message to this Remind app that we have,
Mm.
and she usually gets back to me, especially on Tuesdays and Thursdays.
All
So
right.
yeah, if you got time tomorrow, we can work on it. Or...
Yeah, sounds good.
Cool. Thanks, bro.
Yeah, I'll talk to you tomorrow.
See you tomorrow, bro. Cool.
All right, bye.